Hi, everyone. Welcome to the Generative AI for Automotive online conference. My name is Lishba Jan. As Divisional Director for Automotive IQ, I'd like to welcome you all to the online meeting that we are all part of this morning, afternoon, evening, wherever you're located. I will apologize real quickly for the 10-minute delay. We are having some technical difficulties around, as is always the case with online meetings. But I would like to, of course, make sure that everyone is still going to be sticking around for the whole duration of this event. Quick intro, and I'm going to keep this really, really short to be aware of time, but generative AI as a technology is, of course, disrupting the way vehicles are designed, manufactured, and, of course, experienced. This entire event is, of course, a precursor to the Generative AI for Automotive in-person event that will be taking place in February, the 21st and 22nd in Frankfurt, Germany. Now, today's event is, of course, giving you a sneak peek into how bleeding-edge generative AI technology is being applied in the real world. And you are going to be hearing from one OEM, one Tier 1, and one Tier 2 supplier, how they're making things happen with generative respective organizations. At the February event, however, you are going to be hearing from dozens of OEMs, Tier 1s, and Tier 2 suppliers. If you want to see more details on that event, then you can download the brochure for the February meeting in the media center that you will see on your screens as well. Now, getting back to the order of the day, today's event will not be possible, would not have been possible, I should say, without the support of the event partner, Qritrim. For those of you that are unfamiliar with the company, Qritrim are pioneers of innovation, and they are driven by a relentless commitment to harnessing the limitless potential of artificial intelligence and making it all accessible. The company's mission is to empower businesses to revolutionize the way they operate, make decisions, and drive growth. Their flagship Qi platform is a no-code, low-code generative AI environment that welcomes professionals to explore, experiment, and excel in AI-driven transformations across manufacturing operations. Built on Qi for automotive excellence, Factoid is a suite of Industry 4.0 solutions where your machine data is simplified, complex insights visualized with ease, and multimodal application development thrives. Using Qi's unique artificial domain intelligence, the Factoid expert knowledge system houses solutions like Digital Twin Builder, amongst others. Now, Qritrim's founder and co-founder and CEO is the first speaker for today's meeting. I can see that he is online. We were having some technical difficulties with Sandeep, but as far as I can see, he seems to be online, and we should not have to change the order of today's presentations. Sandeep, if I can quickly confirm you're able to speak into the microphone.
Yes, then can you hear me?
Fantastic. All right.
Perfect.
Just in the nick of time then, guys. Before we move quickly on to Sandeep's presentation, and it is our privilege to have him with us today, I'd like to remind everybody that today's event is being recorded whilst it's broadcast. And if you miss any part of the event, or you're going to watch back any of these presentations or share with your colleagues, then everything is going to be available for on-demand viewing for 30 calendar days from today. So that will then take us to the 11th of January. You can watch everything back at your own leisure. Equally, I would like to, of course, remind everyone that you have the option of sending questions into all speakers. I will discourage you from waiting until the presentation is over. I'd actually say to you, send your questions in as and when your questions come up. We will take them in the order in which they're received at the end of each presentation. With that, I'd like to, of course, introduce you to our first speaker, and of course, the title of his presentation. Sandeep Kumar is joining us on screen. Sandeep is a co-founder and CEO at Qritrim. Mr. Kumar is a partner at Kizki Japan Fund, GAP, and TMP. He's also founder, CEO of Qritrim, an enterprise AI startup, and CEO of Discover Steam Foundation. He's experienced in technology, financing, merger and acquisition, and strategic partnerships. Sandeep advises startups, SMEs, and corporates in education, biotech, semiconductors, robotics, water, and content. He has founded many startups, been a VC, and was a GM at Texas Instruments as well. A really credible speaker to kickstart the event. I will leave you in the very capable hands of Sandeep for the next 30 to 40 minutes, and we'll come back for Q&A at the end of Sandeep's presentation. Over to you, Sandeep.
Thank you very much, Lishpa. Uh, Thank you, everyone. Good morning. I don't know which part of the world you're joining from, so good morning or good evening. Uh, would love to, and thank you for the opportunity. I would love to share uh, something that we are doing. Qritrim is a AI platform company. It started we started it about three and a half years ago. Uh, the idea behind it was uh, to enable different enterprises and industries across the world to develop AI solutions in a very rapid way without needing a lot of engineering and data scientists and software engineers, and still achieve the full potential of what AI could do. Now, uh, what I would say is, our vision or our logo was a future where anyone can know anything, anytime, anywhere, and answer any question that were not possible to answer before. One of the big challenges with AI, the way it is done today, is that in order to build any kind of solution, you have to integrate a lot of different software elements. You have to have data scientists who build their own models. You have to have data ingestion capabilities, data cleansing capabilities, and that's a lot of work, especially for companies who are not in the area of software development. Um, so what we today's discussion, I will focus on one particular platform that has been built on top of Qritrim, and that platform is called Factoid. And the Factoid is a generative AI knowledge network for factory automation. And using that knowledge network that is built, we are able to deploy very quickly, or customers or clients can deploy very quickly different kinds of solutions, whether it is supply chain management, inventory management, predictive maintenance, etc. Uh, by the way, we started this journey before this generative AI became a buzzword in the last year, and uh, the generative AI, boom. If you think about it, it has spawned hundreds of companies who are now uh, building applications on top of the LLMs, and those LLMs are the real, doing all the machine learning and the intelligence gathering and the analysis in the background, and then you build an application on top of it. So Qritrim had the same concept, but it in even a broader sense, um, in that we can ingest and analyze not just text and audio or text and images, but we are able to have been able to ingest, analyze text, images, software code, audio files, video files, behavioral data from social data, location, 3D models, and sensor data, and any other kind of data that you might have, whether it's satellite data, map data, etc. So it not only ingests all those, but it analyzes all that data, just like a LLM analyzes a large volume of text data, and creates models and knowledge out of that data. And so I will share today some of those components as we in the presentation today. One of the things that is challenging in using AI, beyond the domain knowledge, is when you're building AI solutions, how do you understand the particular domain? And if I'm analyzing text or images or numerical data in the context of a factory, how do I understand the needs of that factory? And if I'm analyzing that same document, etc., in the context of a different industry, how do I build a knowledge network around that particular industry or domain. And second thing is, how do you make sure that the data is trusted, meaning it is actually verified, it is secure, it is not bot generated, it has the various compliances that are required, whether it is GDPR, HIPAA compliance for medical, or FINRA for financial, etc. So we have built we'll look at how we address those points today. Second problem in using AI for large applications is the complexity and cost. And we have put together a platform almost like a AI and operating system similar to what Android did for mobile applications. And then, once that was available, a whole range of new applications could be created because the application developers did not have to worry about the underlying details of how the hardware or software stack was working below it. And the third point, which is quite important, especially in this kind of application, is as we are building knowledge networks, how do we maintain the privacy of the data? Especially, every company wants to make sure that their data is private. Whatever knowledge base is created out of their information belongs only to them and does not, get shared with other competitive players or competition. Kind of a weakness that exists today in the LLM approaches, where it is the data becomes a mass pool, and yes, it is good for creating knowledge, but it is very difficult to separate, or isolate that knowledge and keep it private. A slight side comment beyond factory automation, but in automotive in general, our platform is being used for beyond, in passenger experience. So how do you gain consumer insights, understand and create a knowledge base around it that can be leveraged? Quality control, supply chain, manufacturing, we will discuss today, which is part of Factoid, but some of the other and predictive maintenance is part of Factoid. But the platform is also being used for other areas like navigation, vehicle design, and driving experience. Talking about Factoid, there is a number of things it does. One of the most powerful thing it is able to do is ingest all your historical data, whether it is in PDF format, in Excel format, in Word format, in PowerPoints, and create from that information, and also databases, and from that information creates a functional digital twin of your process or your product or your machine or your factory or combination of. This is a tool that not only ingests all that information, extracts and creates a knowledge, it creates a standard taxonomy that you can utilize, or that it utilizes then to make all the documents that may have different terminologies in it. Using the LLM and knowledge base, it is able to create the standard taxonomy, put all the categories in a place, and then it organizes that data into a process flow that you might be using, or a product specification that is a executable product spec versus a static document or unstructured data. It creates a very structured data out of it. Using that, we have deployed and built applications around failure mode effect analysis, where you can build new failure modes For new processes or products, you can create a FMEA in a very quick way. It gives you the insights on whatever historical failure modes there were, corrective actions, root cause, etc. So you can actually capture the historical learning and still build on top of it. We have predictive maintenance solutions. We have asset tracking solutions, inventory management, resource production factory, resource planning, operational productivity, energy management, supply chain, etc. So basically, it is a the platform is called Qi, and it is an AI knowledge builder for enterprises. And on top of it, clients can build applications very quickly. Normally, most of our clients take 2 to 3 months to build an application, which is a very exhaustive application, a very complex application. But since they don't have to do any code development, they don't have to create new models, they don't have to figure out data ingestion and data cleansing, they can just drag and drop and create a new application. And then for different industry domains, we have a library of models that are and taxonomies that are for that industry. We call that artificial domain intelligence. So for the automotive industry or for the industrial factory industry, we have domain intelligence taxonomies built in that allow you to standardize. And even though different documents or sources may be using some adjacent terminology, like somebody may have called something a product and somebody else may have called it a part, the system figures out and harmonizes across a taxonomy. The biggest, one of the most powerful things that we have is the data ingestion. The data ingestion gateway is a drag and drop system where you can basically ingest any kind of data. You don't have to figure out, and it not only takes this unstructured data and structures it, it also figures out based on the taxonomy what is the context of this data and organizes the data in a executable way. What that means, for example, is if I have a machine documentation in a PDF file, as an example, it will ingest it and will create a complete parts list, maintenance, specification, etc. That is now alignable and usable as you build an application on top. So if a machine fails, a particular predictive maintenance problem identifies a particular failure mode on a particular machine. It also will list out what kind of spare parts you need, what kind of corrective action or repair or maintenance procedure you need based on the historical analysis of whatever has been done in the past. So it does the data processing, it can integrate any kind of sensor data, and then it creates a knowledge structure. So a diagram of that would look something like this, where there are various connectors for every kind of data type that we have. You drag and drop those connectors. You configure those connectors to identify or give the label and the source. You put in what kind of privacy and security policies you want to overlay on it, and that is also all drag and drop. There are agents that will go and extract that data from the various sources, whether it is a database, a machine, a SCADA, and it can take in, SCADA interface or any other kind of interface. And then it does filtering on top of it and analysis to create a knowledge base. Second part of this is what we call machine learning as a service, where today, if you want to create an AI solution, you have to understand NLP, you have to understand text, you have to understand image processing, you may have to understand, what kind of numerical statistical models you want to use. What we have done is we have created a library of models that automatically, uh, uh, you don't have to create these models. You can basically take the models, configure them with certain parameters, um, and then utilize them and do the training, or it will do the training and then deploy them. We even have taken it, a couple of other things that have been done in this is you can actually, if you want to deploy, balance the latency and the timing of these models, you can deploy them on the edge. It will compute the resource availability at the edge and partition the model in a way that it optimizes the overall data transmission bandwidth and the latency based on the compute power that's available at the edge versus the core. It looks at the data and also, because of the knowledge base, automatically figures out what does the data structure look like, and organizes the data. For a given application, if you feed into it, the requirements in a model, it actually will come up and propose and suggest what are the different models that would be ideal from the library for your particular use case. And there are trade-offs in which models it will suggest. It might say, okay, you need a higher accuracy, then there might be a latency that comes along with it and a compute requirement that comes with it. So you may not in every case need 100% or 99% accuracy. You may be okay in a particular application with 80% accuracy and reduce your overall compute costs as well as your latency in the system. So you can automatically, so it is a system that has built-in learning, and then the final thing in this is that it is a system on machine learning that has a continuous self-learning. So it's not just a static model. When you deploy it and as it is being used, the models are continuously updated based on the use that is happening. And so they are self-learning models. So this is a kind of a overall block diagram which shows we have predefined models. We also have, if you do want to create your own models, we have a model builder. We also have a library that is third-party models that you can, if you want to use a Microsoft Azure model in the system, you can pull it in and then it automatically. And then it has model monitoring, security, inference, and edge deployment. The third important element of this is the master data management. And this is where the privacy portion comes into play, where now what we have done is we have a public database where all the knowledge base is created, and then we have a private database that is specific to your company, and it creates a knowledge base that is combining the public database with your private data to create a master knowledge base that only belongs to your company. Similarly, when you do the training of the models, the untrained model is coming out of the library, but when it trains on your data set, which is proprietary to your company, the trained model goes into a private database that only belongs to you. So this is a way for us to, make sure that every company's proprietary and data ownership is retained by them and not being leveraged by competitors or by the general public. In addition, we have tools that are built on top with, again, drag and drop, where you want GDPR compliance on your data set, you want personalized information removed, you enable that, and it automatically de-anonymizes all your data, takes out all your PID information, replaces it with generic information, and so that you are fully compliant with GDPR or if you have, in this particular case, you don't need in Factoid, but we have HIPAA compliance for medical data, FINRA compliance for financial data. So those compliance wrappers are built into the system, and you can, easily get your system operating. So this is the security layer, a monitoring layer, and it also does, by the way, it also analyzes the data for corruption, for trust. It is, real data versus bot generated or artificially created data, and it has an element of security built in where, third-party hacking or intercepting that data is blocked out. And finally, we have a tool for visualization of this data or the results. And so now the same outputs, different stakeholders in an enterprise or in a factory might need information about. A marketing person may want to look at the data a different way. Engineering operations person wants to look at a different aspect. So you are able to create a insightful and custom dashboard and visualization, again, using a drag and drop approach. In general, most of our clients have been able to build a new application on top of our platform in a period of 3 to 6 months, and generally closer to 3 months. And the effort required is to build a model, a block diagram of what you want to achieve, and then you use these tools to drag and drop and create that, realize that model, and then you do the training on that model, and then you do the deployment of that model. And the total process is extremely fast and extremely very high end. This is not because it's a combination of simplicity, but yet achieve very high level of accuracy. And this is all generative in the sense that you are looking at all the past data, creating new insights, creating new information, creating new data sets out of it. Now, this is the overall architecture of the 4 major blocks. So we have an advanced model library for computer vision, for GAN, for natural language processing. And it is a library, it is not a single model. So there is a whole set of models that are can be used. You can build new models quite quickly. You can reduce the deployment time and cost by over 90% compared to, putting large teams in place to realize something that you want to do. It can be deployed at the core or the edge, and models can work in your own environment with your own security. It can, and it has data engineering, deep data science, and artificial domain intelligence and powerful AI ML models. So structured, unstructured data, multimodal data, public and private data, external data from industry domains, data from public domains. So it takes all those data sets, creates a knowledge base with a taxonomy that is specific to your particular industry. A quick, these are applications that have been built by our clients. Actually, one client we can disclose, Denso in Japan, is using this extensively, and they built some of these applications. So this is predictive maintenance, where in a conventional predictive maintenance, you need to understand and configure a lot of the equipment. And here, it takes in whatever data sets you have. It takes in the SCADA or the IoT sensor data, however it is coming. You don't have to design or program the system. You just, it figures out from the data set what is relevant information, what is input, what is output, what is the failure mode, looks at your all your maintenance historical records, your failure modes in the past, and comes up with a scheme where you can predict a particular failure, and you can have a certain accuracy and time on that failure. And so it will say, okay, this particular part is or portion of the machine or this component in the machine is likely to fail 80% accuracy in 3 months from now, or 90% accuracy in 3 days from now, or 95% accuracy in 3 hours from now. And that can be used to, and this is the maintenance procedures you will need, and this is the spare parts you will need. And so it can be used by the operations team to plan out their maintenance before the failure occurs based on downtime of the machine or whenever it is not in use. Quality control, there we have customer has built failure mode effect analysis, also inline process control management, and looking at again, looking at all the historical data to use and generate a prediction model, and then use that prediction to make recommended actions, and use those recommended actions to implement and improve the quality and keep your, basically prioritize what changes or changes you want to make to your process. And supply chain optimization, where we can look at where the customer is using it to look at spare parts, look at material handling, look at what is the lead time on the materials, what is the pricing on the materials, what is the costing, and utilize all of that to properly or more efficiently map out what kind of inventories and what kind of piece parts need to be at every machine and overall factory level, and use that. And then same thing on the output side. Digital twin, we are able to create a digital twin of a process by just feeding in all your data. It will output data as in process documents or product documents or machine documents and databases, and it will create a digital representation of that process that then can be utilized by you, by the client to tune the process, look at different variables. But the creation of the digital twin from the information and documentation is you just feed all that in, and it outputs, analyzes using computer vision and LLMs and statistical numerical analysis, and creates a very accurate flow of your entire process and where the trade-offs are, and etc. Same thing you can create a digital twin of your machine, you can create a digital twin of your factory and the factory flow, and all of that can be done within days by ingesting all the information. And the ingestion is all automated in a way because of all the data connectors we have. So you can configure the software within days to come up with, okay, here's the digital twin, and then you can put that digital twin into a functional use. One more example that our client did was, they had, for a lot of their machines, they had electrical diagrams which were not actionable diagrams, and this system took all those drawings, if you might, electrical diagram drawings, and extracted and created a connection diagram and a circuit diagram and a piece part, component information. So now you can look at, utilize that for inventory, or you can utilize that for predictive maintenance. If a particular part fails, then what is the risk of the adjacent parts and what other parts could be damaged? It creates all the loops. And this again is like a tool that you can feed the information, and it outputs everything within minutes of feeding in. So overall, Factoid is a platform. It uses these 4 products from Qritrim, data ingestion as a service, ML as a service, MDM as a service, and data visualization, which is then used to create Factoid, which is a knowledge base for an industry. And on that knowledge base, then the clients can build, or we can build for you, or we have canned applications in each of these areas, which is digital twin, FMEA, inventory management, planning, production, and the color code between the blue versus yellow is the green. The green are already deployed and in actual factories. The blue are in various stages of customer development and training and deployment. With that, I'm at the end of my presentation. We can take some questions. I don't know how much time I have, Alishba, so we'll leave that to you.
Yeah, of course. Of course. Thanks for that, Sandeep. For anything else, I think it was a really, really detailed, really valuable presentation. What I'd like to do, guys, is, of course, open it up to questions to the audience. We will take questions for at least 5 to 10 minutes. What I'd like you to do is, of course, start populating your questions into the Q&A window that appears at the bottom of your screens. I think we have two questions at the very least that are waiting for you, Sandeep. If you are ready, then we can, of course, crack on with those.
Yeah, sure. I'm ready. Can I see the Q&A list, or only you can see it?
No, you should be able to see it as well, Sandeep. They're bottom right corner of the screen. But I can read them out to you, and of course, we can take them in the order in which they've come in.
Below the attendee list, below is preview.
That's correct. Yeah, just beneath the attendee list, you should be able to see it. But I think
so. That's the preview button. No, that's
just to keep it.
Okay, I see it now.
It should be titled Q&A. But
yeah, okay.
I think
now
just to keep it streamlined, the easiest thing for us to do is for me to call out the questions to you, and for you to be able to answer the questions. This way, we're going to be able to take as many questions as we possibly can. So I'll start with the first question, Sandeep. This one comes from a gentleman named Wad Al Masri. He's asking, where does this public database come from?
The public database is an exhaustive analysis of or an ingestion of all the literature that is out there, in technical magazines and conference reports and textbooks, etc. So it's basically a data that is coming out from that public environment, right?
Right.
Versus data that is specific to your particular company, where you might have data sets inside that are not in the public domain.
Right. Well, Sandeep, Alwan has asked a follow-on question as well. I'll perhaps prioritize that one so we can get his questions out of the way. He's asking, how did you use the generative AI in electric diagram extraction? You have fine-tuned existing generative AI models, or you built simple deep learning or machine learning models?
We used deep learning, machine learning models. The LLMs or existing Gen AI for LLM is only for the component naming and terminology, so we can identify which component is what. But then you need a lot more around how do you figure out a particular rectangle is a component? How do you figure out that it has terminals? How do you figure out the electrical connections between that? So there is a lot of electrical diagram symbol terminology that has to be analyzed, and over there different companies might use different terminologies, so we use a taxonomy to understand those terminologies and bring them into a common view, so that then the Gen AI can work on it, whether it is deep learning machine models or Gen AI.
Great. All right. Well, hopefully that answers your question. If you've got a follow-on question for Sandeep, you can see his details on your screen. We'll take a question from a gentleman named Olivier Haas. Interesting question. His question to you, Sandeep, is what is the USP or the unique selling capability of your product compared to alternatives that are on the market? And how are your features presented in comparison to other tools that are out there?
So I think so let's take 2 or 3 different examples, and then maybe that will become clearer. You have, Amazon with a library of models. You have Microsoft Azure with a library of models. In order to build an application, you still need to have a level of software development expertise that understands those models, and then that can be used to build a software application. The big USP on ours is that you don't have to be a software expert and a data science, because the connections on the data, they are connectors. You drag and drop, and you just need to, for example, say the source or directory of that particular PDF file or that data set, and it now analyzes that PDF, figures out what is the structure of that PDF, organizes that PDF into a structured database, converts that from using a taxonomy into different PDFs can be combined, and from that extracts a knowledge base of whatever particular information. Easy to understand example would be if I have a video that I'm running, and if I'm using that for the purpose of advertising, then I want to extract certain things out of that video or image. What are the people? What are they wearing? What are the things? But if I'm using it for tourism purpose, I need to extract the imagery on the background and the relevancy. So this system does all of that automatically, right? You don't have to go in and figure out write software and figure out. Second, on top of it, you might need different models. You don't have to create the models once the data is ingested and cleansed. You don't have to create any models for building your application. The models are there. You drag and drop, and it even, depending on the application, you feed it in your flow diagram. It understands what you're trying to build and will recommend certain models to you and so those are the 2 big things which nobody else is doing. And the analogy I drive is until the ChatGPT, GPT-4 came out, everybody had to do that whole LLM on their own. Once it came out, there are hundreds of companies building applications on top of it. They don't have to figure out how to build the knowledge base on the LLM, right? Now they utilize the LLM for an application. So what we have done is create an equivalent LLM, but it's broader than LLM. It analyzes, not just language. It analyzes images. It analyzes video. It analyzes IoT data. It analyzes SCADA data, et cetera, et cetera.
Great. Sandeep, that's really fantastic. I think there's a lot of questions here for you, right? I think we'll take another 2 questions, and everyone else that has a question or has sent a question, Sandeep and his team will, of course, come back to you offline. Sandeep, I'll call out a couple of questions. It's your preference which ones you want to answer, but all of them sound quite interesting to me, and obviously as well.
So is there a way to capture all these?
How is generative?
Alishbhai, is there a way to capture all these questions and email them to me so I can also answer them offline?
Yes. You after this meeting is over. For the time being, we'll take 2 questions. I think the first one that I can see is how generative AI can be useful, in your opinion. How can generative AI be useful in vehicle diagnostics and prognostics? I don't know if you've got anything to add there.
Generative AI, and if you think about generative AI, it is basically an ability to look at different data sets and from those data sets extract a new data set, let's call it, that is descriptive of the problem, right? So in that sense, vehicle diagnostics, vehicle prognostics, if you have various data sets available, you know, historical database of all your diagnostic information, a generative AI tool can go into it, analyze all of that, and from there create, you know, information and knowledge base where you can query it and come out with solutions, you know, that normally a human being either would not be able to discover on their own because that data set is too large, or may not be able to connect the dots between two different issues. And now the machine learning algorithms can connect the dots and come up with, okay, this is the fishbone diagram, and this is where the fish, you know, where the failure mode occurred, and this was the real root cause. So that level of analysis, and then combine it with the failure mode effect analysis for that system or component or the process, and come out with, you know, a more accurate prediction and a much faster convergence of what the failure mode could be, right?
Great. Sandeep, let's take one final question. This one comes from Ravi Kiran, and they are asking whether this is specific to automotive or just any kind of automation. The way he's hearing it, it is a very generic automation Industry 4.0 application.
It is a very generic Industry 4.0. In fact, I will go even further. It is a very generic application. We have companies using the platform for education AI, companies using it for advertising. But where things become specific is that for every particular vertical, you need a taxonomy and a knowledge base that is very tuned to that particular industry vertical. So when you're talking about automotive, the same information will be analyzed with the automotive taxonomy, and you know, certain things will be extracted, and certain information will not be relevant for automotive domain, and that is removed. So you are, instead of working on a, you know, big mass of data, you tune that data down into a knowledge base that then you use for future, you know, MLAI operations for that particular, you know, industry or application. So there is ADI, what we call artificial domain intelligence, and we have taxonomies and that are built up for particular industries that make that AI ML application development for that industry much more smoother and effective. But the platform is generic.
Great. Fantastic. All right, Ravi, hopefully that answered your question. Of course, Sandeep and his team will follow up with everyone that sent a question, and those whose question did not get answered while we were online, the Qritrim team will come back to you as soon as possible. Sandeep, with that, I'd like to thank you for your time this morning, and of course, the presentation that you've delivered for the audience that we had online. And of course, you'll of course be able to reach out to everyone that has listened in this morning after this meeting is over. Thanks very much.
Thank you very much. Thank you.